Our first nonparametric statistics will be the phi coefficient and the kappa coefficient of agreement.
Basically, we're looking at the agreement between two nominally scaled variables. The agreement between nominally scaled variables can be assessed with the phi coefficient, with percent agreement, and the kappa coefficient.
The phi coefficient is actually the nonparametric nominal equivalent of the parametric Pearson product moment correlation coefficient.
Essentially, it's the correlation between ones and zeros on the x, ones and zeros on the y. We can also look at agreement by looking at simply the percent of agreement. If you passed the test on one occasion, did you pass it on the second occasion? If you failed on the first occasion, did you fail it on the second occasion? We could look at percent agreement. Unfortunately, percent agreement is an overestimate of the true agreement because there are chance agreements that could occur.
Kappa adjusts for these chance agreements.
Here is our example. We have 100 students who were tested twice on the FitnessGram pacer, and when they completed the pacer, it was determined whether or not they had achieved the healthy fitness zone. So they are either in the healthy fitness zone, yes, or failed to achieve the healthy fitness zone, no. We're going to give that test on 2 occasions, perhaps 1 week and then the following week. And we want to see if they achieve or don't achieve the healthy fitness zone on both occasions. We're looking for agreement. We'll do that with the phi coefficient, percent agreement, and the kappa coefficient. Here are our results. Notice we have 100 students. There were 32 students who failed to achieve the healthy fitness zone on both occasions. There were 51 students who achieved the healthy fitness zone on both occasions. Notice there were 17 students who didn't match, who didn't agree. So the percent agreement in this example would be 32 plus 51 divided by 100. So percent agreement here is 0.83 or 83% agreement.
So here are our results. The phi coefficient is 0.678. That's the equivalent of the Pearson product moment correlation. Our percent agreement we've already seen is 0.83, and the kappa coefficient, after removing the chance agreements, is 0.653.
So notice that kappa adjusts the percent agreement downward due to the chance agreements. If you'll notice, in both cases, the phi coefficient and the kappa, which can be tested for significance, percent agreement is generally not tested for significance, but in our case, there's a good deal of agreement between how the students did in achieving the healthy fitness zone on the first test and the second test. In both cases, you would reject the null hypothesis that there's no agreement because the significance level listed on the right is less than 0.001. We'll now turn to SPSS and illustrate how we got this output.
Here's our SPSS data view. We have 2 columns. The first one is the first occasion they took the test, and the second one is the second occasion they took the test. And the values are 0 when they did not achieve the healthy fitness zone and 1 when they did achieve it.
Let's now turn to SPSS and determine how we can calculate the phi coefficient and kappa. Remember, percent agreement you have to do from the cross-tabulation table. Go to Analyze, Descriptive Statistics, Cross-Tabs, put the Pacer Healthy Fitness Zone Test 1 in the rows, Pacer Healthy Fitness Zone Test 2 in the columns. Click on Statistics. You're going to click on Phi and Kramer's V and the kappa coefficient. Continue. OK. Here we have our output, just as we've seen before. Here is what's called a contingency table. The association between how they did on the first test and how they did on the second test. No, no, failed to achieve on both occasions. There's that 32, and 51 people achieved the healthy fitness zone on both occasions. And here we have our measures of association, the phi coefficient and kappa.